Hello everyone, welcome back to another video of our multi-threading in Java series. In this video, we will be starting off with our medium level problems. Today, we will solve our first problem in medium level problems, which is print FizzBuzz using 4 threads. So let me explain you the problem statement in detail. The problem states, given a number n, print using below 4 conditions. Now what are the 4 conditions? First of all, we have to create 4 threads named T1, T2, T3, T4. Straightforward. Now for every number, we have to check below 4 conditions. So if a number is multiple of 3 but not 5, then we have to print Fizz. Similarly, if a number is multiple of 5 but not 3, then we have to print Buzz. If a number is multiple of both 3 and 5, then we have to print FizzBuzz in the output. And if the number is neither divisible by 3 nor 5, then we have to print the number itself. Let's take an example and understand this. So for n is equal to 1, what will be our output? N equals 1. 1 is neither divisible by 3 nor 5, right? So output will be the number itself. So output will be 1 and this will be printed using thread T4, right? What about 2? When n equals to 2, we'll check it is not divisible by either 3 or 5. So again, the output will be the number itself. Therefore, we'll print 2 and this will be printed using T4 again. What about 3? 3 is multiple of 3 but not divisible by 5, right? So what will be our output? Our output will be Fizz. So let's print Fizz and this will be printed using T1 thread, right? 4. What about 4? 4 is neither divisible by 3 nor 5. So the output is number itself. Let's print 4 here. This will be printed using T4. What about 5? 5 is multiple of 5 but not 3, right? So we'll print Buzz here. So output will be Buzz and this will be printed using T2. At last, for n equals to 6. Now 6 is again multiple of 3 but not 5. So what we have to print? Fizz. So let's print Fizz here and this will be printed using T1, right? So this is what we have to do. If suppose some number comes which is multiple of both 3 and 5, for example 15, at that particular point of time we have to print FizzBuzz, right? Now let's look at approach for this problem. So approach will be pretty straightforward. What we'll do, we'll create a class having counter equals to 1 and a variable n, right? So we'll start our counter from 1 and it will move from 1 till n. We'll have to make sure that both these variables, counter and n, are shared between threads because all the threads will use the counter variable to decide whether it's their turn or not, and n will be used as a termination point, right? If our counter has reached value more than n, then we will terminate that particular thread. Apart from that, what we have to do, we have to create 4 synchronized methods. One method will be responsible for printing Fizz, other will be responsible for printing Buzz, third will be responsible for printing FizzBuzz, and the last one will be responsible for printing the number itself, right? Now let's look at the template of our class. How will our class look? So we'll create a class named FizzBuzz. We'll have a counter inside it and a variable n. We'll initialize this n using constructor of this particular class, and we'll have 4 synchronized methods, right? One to print Fizz, then Buzz, then FizzBuzz, then the number itself. After this, we'll create 4 threads outside of this particular class in our main class, and we'll execute this method using T1, this using T2, this using T3, and this using T4, right? And to make sure our counter and n, these both are shared, we will use the same instance of the FizzBuzz class, right? It will become more clear when we start coding it. So let's directly go into our IDE and code this particular problem. So I have already created our main class. Let's go ahead and create FizzBuzz class. Okay, FizzBuzz, right? What this class will do? This will have a variable counter which is equal to 1, right? We'll have a variable named n. Let's go ahead and create a constructor. Constructor will be responsible for initializing the value of n, right? Now we have to create 4 methods, 4 synchronized methods, and all those methods will be responsible for printing different things. Let's go ahead and create a function for printing Fizz. So public void, we'll name this function Fizz while true, right? we'll use a synchronized block, synchronized on this. And what will be the condition here? Condition will be while counter is less than equal to n, we have to iterate till then. And what was the condition for printing fizz? So condition for printing fizz was counter modulo 3 is equal to 0 and counter modulo 5 is not equal to 0. This was the condition for printing fizz. Now if this condition is not met, then what we have to do? We have to wait here, right? Let's go ahead and add exception. Suppose that when a thread comes out of this particular while loop, it will check again if our counter is greater than n. At that particular point of time, we have to break from there, right? After breaking, what we have to print? Print fizz here. So we'll print fizz, and let's go ahead and do printed by thread name. After this, we'll do counter plus plus and notify all the other threads to go ahead and check whether the next value they have to print or not. Now second function, let's go ahead and create our second function. Second function will be named buzz. What is the condition for buzz? When counter is modulo 3 is not equal to 0, but it is divisible by 5. When this condition is not met, we have to wait. This will be same and we have to print buzz here, right? Let's go ahead and print. Now let's go ahead and create a function for FizzBuzz. So FizzBuzz, what is the condition for FizzBuzz? When counter modulo 3, when both number is divisible by both 3 and 5. When that condition is not met, we have to wait. Post that if counter is greater than n, we have to break and print FizzBuzz here, right? What is the last one? Last one, we have to print the number itself. So let's name this number. And when counter is not divisible by either 3 or 5, that condition is not met, then we have to wait. If that condition is met, then we come outside. We again check whether counter is greater than n or not. If it is greater than, we'll break it. And here we'll print the number itself. So let's go ahead and print counter, right? Counter printed by whatever number is there. Then counter plus plus and notify all. I think this looks fine, right? Now let's go ahead and create our main class. In our main class, we'll create an instance of FizzBuzz, new FizzBuzz. Let's go ahead and print till 20, correct? Post that, let's create 4 threads now. So thread 1 equals to new thread. Let's use lambda method here, right? What we'll do here, we'll go ahead and call FizzBuzz dot fizz, right? Surround with try catch. Let's create 4 such threads. Thread 2 will be responsible for calling buzz. Now let's create thread 3. Thread 3 will be responsible for printing FizzBuzz, and thread 4 will be responsible for printing the number itself, right? So number. Let's go ahead and start all these threads. Thread 2, thread 3 and thread 4, correct? Let's go ahead and run this. Right, so fizz is printed by thread 0. So what fizz printed by thread 0, this is correct. 2 also printed by, but 3 should not be printed by thread 0, right? Fizz, buzz. Here number should have been printed 1 and 2. What is going wrong here? Let's go ahead and check our FizzBuzz function. So counter is less than equal to n. Are we checking the condition right? Multiples of 3 and not 5, right? Multiples of, oh, so we have put OR condition here, but we have to put AND condition here, correct? Oh, let's go ahead and print and do it, and because both these conditions should meet, right? for this thread to print either fizz or buzz or FizzBuzz. We have used or here. That's why it was failing. Let's go ahead and run it now. Yes, 1 is printed by thread 3, 2 is printed by thread 3, correct? Then all the numbers are printed by same thread, right? Buzz is also printed by same thread, which is thread 1. Fizz is also printed by same thread, which is thread 0. And FizzBuzz is printed by thread 2, right? So we have respective threads. So these threads are named randomly by our JVM, but the main thing to notice here is one thread is responsible for printing one kind of a thing, right? So thread 3 is responsible for printing only numbers. Thread 1 is responsible for printing only buzz. Thread 2 is responsible for printing FizzBuzz, and thread 0 is responsible for printing fizz, right? So our program is working as expected. Now, one of the important things you should notice here is the nature of program here is such that our program works, but one of the very good habit is to always use notifyAll inside the if condition wherever you write break, right? Now, why is that? This I have already explained in my earlier videos, but I'll tell you shortly. This is just to make sure that all the threads which are in waiting state comes out of the waiting state, again checks this condition and breaks out of the loop. This is just a fail safe to ensure that our none of the threads go into infinite wait state, right? At the time of breaking, when the counter is n, you just do notifyAll. So even if some thread is in waiting state, it will come outside, it will check whether counter is greater than n or not, and it will break itself. Now let us see, is this the most optimal approach to print FizzBuzz using 4 threads? Let's go on whiteboard and understand if this is the most optimal approach or not. Now, suppose our n is equal to 15, T1 responsible for printing fizz, T2 for buzz, T3 is executing this method, and T4 is executing this method. When n is equal to 15, this does not matches the condition whatever we wrote in fizz function, right? So this thread will go in wait state. This thread will also go in wait state. For 15 is divisible by both 3 and 5. So this will be in running state, right? And this will again go into wait state number. So all these 3 threads are in wait state, and this one is in running state. After printing FizzBuzz, it goes ahead and calls notifyAll, right? When it calls notifyAll, at that point of time, all these 3 threads are again woken up, right? The value of n is now 16. After printing notifyAll, after executing notifyAll, all the threads T1, T2 and T4 are in running state. They again go in their while loop and check whether they are responsible for printing 16 or not. So T1 checks, it is not divisible by 3 and not divisible by 5. So it again go in wait state. This will also go in wait state. This will go in wait state, and this will go in running state, right? So what is the problem here? These 2 threads were already in waiting state. We still woke them up. We still made them recheck the condition, right? And then we again put these 2 threads in waiting state. This was changed from running to waiting, that is fine. And only T4 was able to move forward and go into running state. So this is an extra overhead, right? We are waking the threads from their wait state, making them recheck the condition, and then again putting them into wait state. So when n was equal to 15 and only T3 was in running state, wouldn't it be better if we just wake up the required thread? What if we just wake up T4, because we already know that n is equal to 16. So T4 will wake up and T4 will print this and will put T3 from running to wait state, right? Instead of waking up T1 and T2, we'll just wake up T4. So if we have this kind of mechanism, this program will become more efficient. Now, do we know the concept that will be able to solve this? So basically we can solve this using 2 things. One is using reentrant lock and condition, and the second one is using semaphores. Since we haven't covered yet reentrant lock and condition, that's why we'll go ahead and solve this particular problem efficiently using semaphores, and you will see how. So let's look into our intuition. We have 4 threads. What we will do is, we will put any 3 thread in waiting state initially and give control to any single thread. Suppose we have put T1, T2 and T3 in waiting state, and we have given the control of program to T4. Now what is the job of T4? Initially, suppose counter is equal to 1, right? It will check which thread is responsible for printing counter. So counter equals to 1. Before that, T1 is responsible for printing fizz, T2 is responsible for printing buzz, T3 is responsible for printing FizzBuzz, right? And T4 is responsible for printing number itself, right? Okay, so first step. When counter equals to 1, which thread is responsible for printing the counter? T4 itself is responsible for printing the counter. So it will go ahead and print it, right? And value of counter will be 2. It will check again which thread is responsible for printing the counter itself. T4 will go ahead and print 2. Now value of counter is 3. It will again check which thread is responsible for printing the counter, right? So it is divisible by 3 but not divisible by 5. So thread T1 is responsible for printing Fizz, right? So what it will do, wake that particular thread and put itself in wait state. So T4 will go ahead, put T1 in running state and put itself in waiting state, right? These two were already in waiting state. It will go ahead, put T1 in running state and put itself in waiting state. What will T1 do? The woken up thread will print the number. So it will go ahead and print the number, or it will print what? It will print Fizz, correct? It will again give control back to T4. After printing Fizz, it will go ahead and give control back to T4 and put itself in waiting state. And it will again put itself in waiting state, right? So again, the control is with T4. Value of counter is 4. Again, it will check which thread is responsible for printing the counter. And this goes ahead in a loop unless our counter reaches the value of n, right? Now, this structure seems to be too good to be true, right? But we can make this happen using semaphores. Let's see how. So to simulate whatever we have explained here, we will create 4 semaphores. One semaphore will be Fizz, second will be Buzz, and third will be FizzBuzz. All these 3 semaphores will initially have 0 permits, and we will make T1, T2, and T3 to wait on these semaphores. How we make threads to wait on these semaphores, we have already covered in our semaphore video, right? So we'll make T1, T2, and T3 wait on these semaphores. To put T4 in control, we'll create a number semaphore which has initial permit of 1. So initially, to be in control, T4 will go ahead and acquire the number semaphore, right? So count will change from 1 to 0. Then it will check which thread is responsible for printing the number. So suppose when n is equal to 3, it will check which among these 3 threads is responsible for printing n equals to 3, or we can say printing Fizz, right? So it checks, okay, so T1 is responsible for handling numbers which are divisible by 3 but not by 5. So it will go ahead and release the semaphore of this particular thread. So T4 will go ahead and release the semaphore of T1 here, right? So semaphore of T1 will be released. Therefore, the number of permits available here will change from 0 to 1, right? As soon as the permit changes from 0 to 1, T1 will acquire its semaphore, right? T1 will acquire the Fizz semaphore. That particular thread, which is T1 in this case, will print either FizzBuzz or FizzBuzz, right? So T1 will go ahead and print Fizz, and then it will release the number semaphore. This is very important. Why it will again go and release the number semaphore? Because it again wants to put T4 in control. After acquiring the number semaphore for the first time, the permit have changed from 1 to 0, right? So when it will go ahead and release the number semaphore, T4 will be in control and it will again be able to acquire the number semaphore, right? So it will go ahead and release the number semaphore so that T4 becomes in control. And this particular thing will go ahead and repeat in loop, right? So I hope you are clear with this. Let's go ahead and write the code. While I write the code, I'll explain and it will become more clear to you guys. Okay, now let's go ahead and code it. So let's first create a class named FizzBuzz Semaphore. FizzBuzz Semaphore, right? What we have to do here, let's create a variable named n, then we want a counter which starts from 1, and we have to create 4 semaphores, right? So semaphore, first let's create Fizz semaphore which has permit equals to 0. Then we'll create Buzz semaphore, FizzBuzz semaphore, and at last number semaphore, right? Number semaphore should have permit equals to 1. What else? Let's go and create constructor. Constructor will be responsible for initializing n. And now let's write 4 functions which will be responsible for printing FizzBuzz, FizzBuzz, and number. Yes, so Fizz, what will Fizz do? So we'll make a while loop. And so what will Fizz do? Initially Fizz has to be in wait state, right? Thread running Fizz has to be in wait state. So we'll go ahead and call fizz.acquire here. And since it has 0 permits, so this will wait, right? Now in later point of time when this particular thread has something to acquire on, so it will go ahead and check whether counter is greater than n or not. If counter is greater than n, it will break from the loop, right? If not, then it will go ahead and print out what? Print out Fizz. So we'll print Fizz, and let's print thread name also, Fizz printed by whatever name. After this, what we have to do? We have to increase the counter. So let's do counter plus plus, and post that we have to give the control to which thread? To number thread. So we'll do number dot release. Correct. Same thing we'll do for buzz and FizzBuzz. We'll go ahead and type buzz here. Buzz will be printed, and we'll acquire buzz, right? Similar thing for FizzBuzz. FizzBuzz. Here FizzBuzz dot acquire, and here print FizzBuzz, right? After this, last is number. Now number, this is the main controller. What we'll do here? Initially, we'll do number dot acquire. Number will have one permit, so it will proceed. After this, if count is greater than n, what we need to do will come here later, right? First, let's go ahead and write all the conditions. So if counter, okay, counter is already, we know it is less than equal to n. So we'll go ahead and check if counter modulo 3 equals to 0 and 5 is also equals to 0. If both are equal to 0, then what we have to do? We have to go ahead and release FizzBuzz, right? FizzBuzz dot release, and that's it, correct? Else if counter modulo 3 is equal to 0, then what we'll do? We'll go ahead and release Fizz dot release. Else if counter modulo 5 is equal to 0, we'll do buzz dot release. Else if none of the condition is true, then we'll go ahead and print counter, system counter, and this is printed by this thread. Post that we also have to do counter plus plus, and again the control will be with number thread only, so we'll do number dot release here, right? Now when counter is greater than n, this particular condition, what we have to do? When counter is greater than n, we want all the threads which are running FizzBuzz, FizzBuzz to get out of their loop, right? Get out of their waiting state and terminate the execution. So all the threads will be waiting on their respective semaphores. So we'll go ahead and do fizz.release, right? So after fizz.release, it will come out, it will check counter greater than n, and this thread will also break from this while loop, right? Similarly, we'll do buzz.release and FizzBuzz.release, right? After doing this, we'll go ahead and break from the thread which is executing the number method also, correct? Now let's go ahead and create a new class named FizzBuzz Semaphore main, right? Main class. First, let's create a main method. After this, we'll create FizzBuzz Semaphore, and let's print up till 10 initially, right? Now we have to create 4 threads. Each thread will be responsible for calling their respective functions. We'll use lambda functions, and here our thread 1 will go ahead and do FizzBuzz Semaphore dot fizz, correct? What is the issue here? Surround with try catch, correct? And we'll copy this 4 times for all the thread. Thread 2, what it will do? It will go and do buzz. Thread 3 will go ahead and do FizzBuzz, right? And thread 4, method call expected fizz. Wait, one minute. What's the issue here? Okay, FizzBuzz we have to call, right? FizzBuzz and FizzBuzz Semaphore dot. What will this do? This will go ahead and create call number. Now let's start all these threads: thread 1, thread 2, thread 3, and thread 4. Right now, let's check once again. If I go ahead and run this program, I think this should work fine. Let's go ahead and run this. Correct. Thread 3 is responsible for printing numbers. So 1, 2, 4, 7, 8 is printed by thread 3. Thread 0 is responsible for printing fizz. Thread 1 is responsible for printing buzz. Thread 2 is not here because we haven't printed FizzBuzz yet because there is no such number. So for testing purpose, let's go ahead and print till 15. And we'll see now FizzBuzz is also printed using thread 2, correct? So this is the optimized version using Semaphore, and which is working exactly as expected, correct? This is correct, everything seems to be correct, and our output is also correct, right? I hope you are clear with both the non-optimal approach as well as the optimal approach, right? This optimal approach can also be solved using reentrant lock and condition, which we'll be seeing in the next video, right? We'll learn the concept reentrant lock and condition, how it works and how it can be used in these kind of problems, right? Now, with respect to Semaphore, I have went a little faster in this video. Reason being, I have already explained Semaphore in details in my last 2 videos. So go ahead and watch it completely if you have any doubt in this approach. Apart from that, wait notify approach, which we did earlier, that was exactly similar to, that was somewhat similar to what we did in odd even printer problem, right? So I hope you liked this video, you understood this concept. So please support me, please like this video, subscribe to my channel, and I'll see you in the next video. Until the next video, stay safe, stay healthy, bye-bye.